In the 1970s, the coastlines of England and France witnessed a sight that felt like a glimpse into a high-speed future. Massive machines, the size of a small apartment block, would roar out of the water and glide effortlessly onto the concrete pads of the coast. These giant SRN-4 hovercraft were the heavyweights of the sea, carrying hundreds of passengers and dozens of vehicles across the English Channel at speeds no traditional boat could ever hope to match. They needed no deep water docks, no complex harbor infrastructure, and almost no contact with the water itself. It seemed as though the age of the conventional ship was coming to an end. Yet, today, if you want to see one of these legendary giants, you won't find it at a busy ferry terminal. You will find the surviving Princess Anne sitting silently in a museum, a relic of a dream that stalled. So why did one of the most futuristic vehicles ever built almost completely disappear? The largest commercial hovercraft eventually carried roughly 60 cars and more than 400 passengers, yet the cross-channel service came to an abrupt end in 2000. It wasn't simply because hovercraft were dangerous, outdated, or replaced by one single invention. Their disappearance was caused by 6 distinct problems that slowly combined, and the final one had almost nothing to do with engineering. Understand how these incredible technologies work to understand why they fled. Hovercrafts build their own environments. Fans on the craft force large amounts of air beneath the hull, which a flexible rubber skirt catches to provide a pressurized cushion. This pressure lifts the boat several feet above the water, freeing it from friction. Giant propellers on top give forward thrust and control while the air cushion generates lift. The vessel can easily cross water, beaches, dirt, ice, and shallow regions because it floats on air. The hovercraft's main selling feature was amphibiousness. A hovercraft sped up the transition between land and sea at a period when ships were slow and hampered by tides and port depths. Maintaining a hundreds-ton aircraft requires huge power output. After proving this worked, engineers created a flying ferry-like boat. The SRN-4 defined hovercraft's golden age. This contraption symbolized British engineering at its best during the hovercraft period. Commercial cross-channel operations began in 1968, and the world marveled as these ships changed international travel. Early versions carried 250 passengers and 30 cars, but demand increased and the machines improved. Later models could hold 60 automobiles and 400 people. The English Channel boat ride, which used to take nearly an hour and a half, now takes 35 minutes. It was a spectacle as well as transportation. Passengers would sit in aircraft-style seats, hear massive propellers, and feel the vehicle lift off the ground as the turbines spooled up. Seeing automobiles emerge from the nose of a boat that had just been sailing at 60 knots was a vision of 21st century travel decades early. However, expanding the hovercraft solved the capacity issue but worsened a deeper issue. The electricity needed to run these monsters was the first obstacle. Because of physics, a conventional ferry stays afloat and needs electricity to move through the ocean. A hovercraft fights gravity continually. It takes huge continuous force to move ahead and suspend its entire weight. 4 marine gas turbine engines, modified aircraft engines, powered the massive SRN-4. These engines were engineering marvels but thirsty. This caused intense economic conflict for operators. Greater people necessitated a larger boat, but greater lift was needed. More lift demanded more power, which exponentially increased fuel consumption. When fuel prices were low in the 1960s, this was affordable. The 1970s energy crisis raised fuel prices, making an already tough business model worse. Hovercraft were faster than ferries, but every minute they saved was pricey. The hovercraft skirt, which gave it superpower, became its biggest technical weakness beyond fuel costs. The craft's flexible rubber skirt allowed it to traverse over different surfaces and absorb waves, but it was awful to maintain. This component endured salt, debris, high-speed water impact, and concrete landing pad friction in the open sea. Even little skirt damage might ground the craft since it maintained the air cushion. Sections needed frequent inspection, repair, and replacement. Local shipyards didn't sell this part. The machines required specialized parts, skilled mechanics, and specific facilities. Maintaining the tiny fleet of large hovercraft got expensive as the manufacturing industry consolidated and the fleet aged. The unique nature of hovercraft technology prevented economies of scale to lower costs. Even with amazing machines, engineers couldn't control the sea. The hovercraft was speedy, but choppy water might defeat it. It is a prevalent misunderstanding that hovercraft were risky, but bad weather made passenger comfort and timetables problematic. A hovercraft impacts a massive wave at great speed, not slices it like a ship hull. The heavy collisions, window spray, and gas turbine noise and shaking made for a rough ride. The Princess Anne was damaged by waves in February 2000 despite operating within its restrictions. A huge high-speed hovercraft could struggle in confusing seas. More passengers valued consistency and comfort over crossing speed. In the late 1990s, would you rather take a slower, costlier, and more stable route than a stunning but potentially bone-jarring 35-minute trip that could be canceled due to high winds? While the hovercraft suffered, its competitors kept on. The hovercraft did not compete with 1960s freezing technology. Conventional ferries improved. New designs increased vehicle and freight capacity, allowing operators to move more goods and people per trip. As floating destinations, these ships had luxurious passenger rooms, restaurants, shops, and lounges. Standard ferries could generate money from big vehicles and commercial freight, which hovercraft couldn't carry in huge numbers, and their passenger costs were much lower. High-speed catamarans provided a compromise. These twin-hull ships crossed quickly without the energy and maintenance-intensive air cushion system. Hovercraft were optimized for crossing speed. However, its competitors were winning on price, capacity, comfort, and freight. No contestant scored the winning blow. It was built under the English Channel. In 1994, the Channel Tunnel opened, changing everything. For the first time, Britain and continental Europe were connected. Hovercrafts couldn't beat this competition. British legislative talks in 1973 anticipated that a tunnel may remove cross-channel hovercraft services, and they were right. The tunnel competed for similarly time-sensitive passengers as the hovercraft. The tunnel allowed cars to hop on a train shuttle and cross in a similar time, regardless of weather. It rode smoother, was independent of sea surface conditions, and had more long-term capacity. The hovercraft's speed advantage was less important when regarded the entire route, including loading and unloading. Because operators made money in other ways outside ticket sales, the hovercraft may have thrived as a niche luxury service. The final surprise was a tax code change. Duty-free shopping dominated cross-channel operators' revenue. Profits from selling beer, tobacco, and perfume onboard subsidized hovercraft operating costs for decades. Operators lost a major revenue stream when intra-European Union duty-free sales terminated in 1999. The SRN-4's high fuel and maintenance expenses were unsustainable without the retail cushion. The last large cross-channel services stopped in October 2000. The hovercraft faced expensive fuel, aging machinery, specialized maintenance, restricted freight capacity, rough water interruption, better ferries, high-speed catamarans, the Channel Tunnel, and lower onboard revenue. No single issue killed the gigantic hovercraft. Its business model was slowly engulfed. Hovercraft disappearance is a myth. Hovercraft technology persisted because of its amphibious capabilities, but giant car-carrying versions disappeared from important routes. Hover travel still runs a successful scheduled passenger route between Southsea and the Isle of Wight, taking around 10 minutes. This service works since the voyage is short. commuters benefit from direct beach access, and the vessel saves significant time compared to a ferry. Modern hovercraft are needed for search and rescue in mudflats, shallow water, ice, and flooded areas where no other vehicle can go. They provide vital military, security, and humanitarian functions worldwide. Instead of failing, the hovercraft found its niche in specialized conditions. The hovercraft's narrative teaches transportation history. A new technology needs more than flash and speed. It must beat its predecessors in cost, dependability, capacity, maintenance, and comfort. The hovercraft was a fantastic engineering solution, but it was used too liberally to replace the ship. Its main advantage, the capacity to cross transitional terrain without a dock, is helpful in some places, but unneeded and expensive on established ferry routes with docks. The hovercraft was a unique tool that briefly tried to rule the globe. Princess Anne's survival in the museum isn't a failure. This machine revealed the impossible. It hoisted hundreds of people and dozens of cars above the sea, proving mankind could fly. Transport history is rarely decided by the most futuristic machine. The machine that makes the same trip reliably, comfortably, and most importantly, profitably wins. The big hovercraft may have left the English Channel, but it represents an age when we dreamed of faster, louder, and more adventurous travel.